All right. Now this is going to be the explanation for problem one, example one. So uh, you should be looking at this page at the review station for problem one. Um, okay, so let's read through the problem. It says Kent wanted to measure the velocity of the train that runs near his house. So he set up an experiment to measure how far it would go each second. The data he collected is in the table to the right. So what we can see over here to the right is that I've got data. So I've got my seconds and the position, or how far it went after each second went by. All right, so I'm going to have to use that data to create, it says draw a position versus time graph, x versus t for the train on the graph to the right. Remember to label and scale your axes properly, include units, plot the points, draw the best fit line to the data points. Okay, so let's go ahead and let's try and do that. All right, so as I look down here, this is going to be x versus t. So remember that units are going to be super important. So I've got t, that's in seconds. That's time in seconds. If you don't have that label, you won't get full points. And this is going to be x for position, and it's in meters. So everybody should be able to get that point right. Just label. It's very easy. Okay, now time, I see that I go from 0 to 5. So, get the mouse out of there. I'm just going to go ahead and label my ones down here. All right, so we're going to start off at 0, and then we're just going to go 1, 2, 3, 4, 5. Go ahead and fill the whole thing in. 7, 8, like that. Okay, now let's try and figure out. All right, so I'm going to go from 0 up through 175. So from 0 to 175. So I've got 1, 2, 3, 4, 5, 6, 7, 8 lines. Let's see, I need to get up to around 200. So let's see if I'm at 1500. Yeah, that'd work. Okay, so I'm going to count by 25s. But I'm only going to count every other line. So I'm going to go 50, 100, 150, and then 200 like that. Okay, that's going to make these things fit nice. All right, now let's go ahead and let's draw some data in. So I know that we start off at 0, 0. All right, cool. 0, 0. Let's put a dot there. I'm going to use a different color. How about blue? 0, 0. Now 1 and 35. Okay, so 1 is here, and I think 35 is going to be somewhere right about there. Okay, 135. 270. I think 70 is going to be somewhere right in that ballpark there. Oh, wait. That's not right. Halfway between the two would be 75, so I got to be a little bit below that line. There we go. Now 3 and 105, so I go to 3 and then just above the 100 line. Ooh, what is that? I don't want to do that. Sorry about that, guys. Just above the 100 line. All right, and then 4 and 140, so 4 is going to be just below the 150 line. And then 5 and 175. Okay, so 5 and 175. All right, now I want to go ahead and draw a line of best fit. It'd be good for you to use a ruler or a straight edge for this, but I'm just going to go ahead and freehand it. There's my line of best fit. All right, so here's what I like to do is a little double check for myself, okay? Let's look and see what they asked for. They said label and scale your axes. Okay, I think I've labeled my axes because I've got time versus seconds, and I've got time in seconds and position in meters, and I've got a nice scale. So I'm just going to mark that off. So I labeled and scaled my axes. It said include units. Yeah, so I see down here. All right, zoom in. I want to zoom in. All right, well I've got, oh no, don't do that. I've got seconds and I've got meters, so I included units. I didn't just put T and X. Plot the points, I definitely did that. And draw a best fit line, I did that as well. Okay, so I did everything they asked me to in the problem. All right, calculate the velocity of the train. Now for this one, I'm just going to go ahead and I'm going to use my very first point and my very last point. So I've got XF, XI, TF, and TI. Now XF, the final position, if I, let's use green, okay, so if I trace myself over to the final position, I see I'm going to have 175. So 175 is my final position. And then if I look down here, I know that I started at 0, so my initial position was just 0. Now, it's not always 0. We have to remember to look at the dots. It's not always 0 in these things. Now, it wants my final time, so I'm going to draw that all the way down, and I see my final time was 5. Okay, so 5 is my final time. And I look over here, my initial time again was 0. Should put a 0 here. Look at that. There we go. My initial time is 0. Okay, cool. Now, I'm going to take my XF minus XI divided by TF minus TI. Okay. Now, XF. So I need XF. Well, I look over here and I see that XF is 175. So I'm going to take 175 and I'm going to put it in the place of where XF was at. Now, XI, I will go over here and I look and I see, hey, look, XI is 0. So I'm going to plug in a 0 in place of XI. All right, let's use a different color. I need TF. All right, well, look, there's TF right there. It's 5. And then, let's use purple. I need TI. So I look and I see, look, there's TI right there. Well, it's 0. So I'm going to take that 0 and I'm going to put it there. Okay, so look what happened. My 175 went there. My 0 went there. My 5 went there. And this 0 went there. Now I'm just going to go ahead and I'm going to do the math. And I'm going to go 175 minus 0 is 175. And then 5 minus 0 is just 5. Okay, so 175 divided by 5. I'm just going to go ahead and, oh man, my phone has a calculator on it. Okay, who knows what 175 divided by 5 is? Let's see. Who has my calculator? What do you guys think? What's 175 divided by 5? Oh yeah. It's 35. Now, my answer is 35. I got to look and see. That's meters per second. So my answer is 35 meters per second. All right, cool. All right, so there's the answer to the first part. Go ahead and box that answer in for me. I really appreciate that. Now, velocity versus time. Okay, draw the velocity versus time graph for the motion of the train in the graph below. Remember, I got to label and scale, include units, plot points, and draw the best fit line. Okay, so remember that trick that I told you. First, I know this is time in seconds. Remember, this is a velocity versus time graph. So this is V, and that's going to be in meters per second. All right, cool. So I've labeled, look at that, label, cross that off. Now to scale my axes, okay, I'm going to go ahead and I'm going to use the same scale that I used on the position versus time. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, like that. Now I'm not going to use the same scale that I used up here because now I'm talking about velocity. All right, well, I know I need 35. All right, so if I count by 5, it'll be 5, 10, 15. No, that won't work. How about tens? Let's count by 10. So I'm going to have 0 there, and I'm going to go 10, 20, 30, 40, and then I got to go below 0 as well. So I got to go negative 10, negative 20, negative 30, and then negative 40. Okay, so it's nice and even. So look at that. I scaled my axes. We'll mark that off. All right, and I need to put 35 meters per second. So I know that for 5 seconds, this thing's going to go 35 meters per second. So I'm going to draw this in red. So I'm going to go halfway between 30 and 40, and we're going to see 35 meters per second. That's a little bit high. That's okay. It doesn't have to be perfect. 35 meters per second, a nice flat line. That means that the velocity was constant. So it stayed the same speed for all 5 seconds at 35 meters per second. Okay, there we go. I included units, I plotted points, and I drew my line of best fit. All right, cool. So there we go, guys. That's number 1. Hope that helped.